Alright, so we're going to talk about Module 17.6, which is solving systems of linear and quadratic equations. So if you remember, the linear equation is basically a straight line. So you have your y equals mx plus b, where b is your y-intercept and m is your slope. And then the other ones are just the quadratic equations. So if you want, they've already graphed the quadratic equation there. So now g of x, it's saying negative x minus 2. So our y-intercept is at negative 2, right here. And it's going to go down 1 to the right 1. So this would be the quadratic equation for g of x. Now we'll do the next one, h of x, in red. So remember, y-intercept is negative 6. And then your slope is up 2 over 1. So that's h of x. And then the next one, we'll go with that blue. So negative 5 is your y-intercept. And then up 1 to the right 2. And that's j of x. So if you look, you can look at g of x. How many solutions exist? That's how many times that straight line actually crosses the parabola. And it looks like it has 2. Look at the graph for h of x. That's the one in the red. So it crosses 1 time. And then the j of x, 0 times. So remember, you can have 0, 1, or 2 solutions. So basically, a system containing a quadratic and a linear equation can have 0, 1, or 2 solutions. So we're going to talk about solving systems graphically. One way to solve a system is to graph both equations and then find the points where they intersect. So the steps here, graph the quadratic function. So the vertex is goes to the left 1 and down 4. So our vertex is going to be down there. Then you can make an XY chart to plug in some points. Then you have to graph the linear equation. So with g of x, negative 2 is your y-intercept where it crosses the y. So you plot at negative 2. Then you're going to go up 2 over 1, up 2 over 1, and then connect your dots. So there's another way you can do this, and I would suggest using Desmos. So here I've already plotted that. This is that example on page 670. So I have f of x equals x plus 1 squared minus 4, which is the purple parabola. And I have g of x equals 2x minus 2, which is the black line. And then if you just see, it crosses this 2 times. At 1, 0, and negative 1, negative 4. So you can do the same thing for the your turn problems. So like on number 3, it says f of x equals, let's do negative 2, x plus 2, and parentheses squared, plus 8. So there's our parabola. And then the next one is going to be our g of x equals 4x plus 16. And it graphs them for you. So all you have to do is just take a look here. We have negative 4, 0 is one point, and negative 2, negative 8 is the other point. And that is the answers for number 3. So that's how you can solve systems graphically. Now, the next way that we have to solve this is algebraically. So this is another way that you can do this. So solving systems can also be solved algebraically using the substitution method. So there's a few steps here. Your first step is going to be take your f of x and your g of x and substitute them in for y. So that's going to be a y. That's going to be a y. So it just says rewrite the related equations. Y equals x plus 1 squared minus 4, and y equals 2x minus 2. Now, step 2, you have to set both equations equal to each other. So you have x plus 1 squared minus 4 equals 2x minus 2. Then you're going to have to solve it. So what we did here is they took your x squared plus 2x minus 3. So they factor that out. And you're left with x squared minus 1 equals 0. And this is a difference of squares. So you got x minus 1 times x plus 1 equals 0. And since you solve for x, it would be x equals 1 and x equals negative 1. Then you have to plug those values into the linear equation to solve for y. The linear equation is definitely going to be easier than solving for the other ones, for the quadratic. All right, so let's take a look at number 6. So we'll go here. Okay, so number 6, they're already set into y equals. So we're going to have our 3x squared plus 4x minus 2 equals, and then you have negative 20x minus 23. So remember, you're going to have to get all the letters on one side, all the variables on the other. So I would add 20x plus 24x, and then we're going to add 23. So we would get plus 21. So now you can, and then we'll have equals 0. So now you can actually factor this out. Let's factor out a 3 first. X squared plus 8x plus 7 equals 0. So what two numbers multiply to get to a 7 that add to get to an 8 is going to be 7 and 1. So it'll be x plus 7 times x plus 1 equals 0. So then what we're going to have to do is break this up into our two equations. So x plus 7 equals 0, x plus 1 equals 0. And then when you solve, we're going to subtract 7. So x equals negative 7. Here we're going to minus 1, x equals negative 1. So we have x equals negative 7 and x equals negative 1. Now what we're going to have to do is plug this into our linear equation, the y equals negative 20x plus 23, and that way we can actually solve for our y's. So x is negative 7, x is negative 1. So we're going to plug it into our y equals negative 20x minus 23. So in the parentheses is where we're going to plug in our negative 1. So negative 20 times negative 1, y equals 20 minus 23, y equals negative 3. So you get negative 1, negative 3. Now the next one, we're going to plug in, instead of the negative 1, is going to be our negative 7. So negative 20 times negative 7 is positive 140 minus 23. So y equals 117. So now x, negative 7, 117. That's another way you can solve it. If you're more comfortable doing it graphically or with Desmos, go for it. Whatever's easier for you. If you like the algebra way, that's fine. If you like setting up the equations, that's fine. It's just another tool in your toolbox. All right, so we're going to go back to the next part where it just says solving using technology. This is the way that I prefer to do this. Whoa. All right, so basically you have your two equations, and they're right here. So solve the system. You're going to have y1 equals 2x. So we're going to start. We'll go to Desmos. We'll just put it here. So g of x equals 2x. That's fine. Then the next one, you can do f of x. And it was negative 16x squared plus 175.5. So negative 16x squared plus 175.5. And now what you're going to have to do is find where the intersection points are. Now the intersection points, here's one, but since we're dealing with time, this is actually a negative number, and you're not going to have a negative time. So you're going to look at this next one. So we'll get rid of that one on the left. So your x value is 3.25. So the coil pack hits at t equals 3.25 seconds. So that's a way you can use Desmos for this. On number 7, it says a window washer is ascending on the side of a building that's 520 feet tall at a rate of 3 feet per second. So it has both of your equations. So we'll go g of x equals 3x. And the next equation is y equals negative 2. We'll just go 2x squared plus 520. Okay, so now you might have to zoom out a little bit. And now the purples are parabola. And we want to say at what time do the supplies reach the window washer? So we're not going to have, on the negative side, we're not going to have a negative number. But you can see where they both cross right here. And it's 15.392 seconds. So in the book it says it's 15.39 seconds. So personally, I would use Desmos or a graphing calculator for all these, but it's up to you, however you want to do it. If you have any questions, please reach out to me and I can help you out with this. Email is always the best way. Thanks a lot. Have a great day.